All right, so now we're going to talk about polynomials. And polynomials are the sum or difference of monomials. So in other words, we're just going to join up some monomials, like what we've been working with pluses or minus signs. When we talk about standard form for the polynomial, this means we want the highest degree first. And typically we can think of the degree as being the power, the exponent. Now, sometimes there are some that are a little bit tricky because then they start having more than one variable. But typically when we're worried about putting them in standard form, we will just have exponents on one variable. We won't see too many things that I'm going to ask you to put in standard form that look like 5 and 6. They're just going to have one variable, not two variables. So, for instance, if I want these in standard form, then I would go 2x to the second plus 3x plus 1. So, highest power, think about it in the real world. Whoever's got the most power gets to go first. So whoever's got the highest exponent gets to go first. Be sure that you take their sign with them. So the negative there is stuck to that k. Constants, they're like the variable to the 0 power, and so they go at the end. So highest power, work your way down. So this one we just need to do one little switcheroo. Put that minus w here, and then the plus 28. So here I've got negative n cubed. Don't have any second power, and then n, and then 24. So polynomials get classified by their degree, and the degree would be the sum of the highest monomial sum of exponents. So typically, if it's just one variable, it's just like third degree. Number 2 would be third degree, would be 3 as far as the degree. Number 1 would be a 2. But if I had something like number 5, this term that has a squared and b squared, this term is a degree of 4. Because you add those two exponents together. And then the whole thing is considered to be that degree because that's the highest power of any, or the highest degree of any of them. So for our purposes, when we think about degree, we're going to think about it being the exponent, the highest exponent. So the highest exponent, because we're going to deal with ones with just one variable at a time. So the highest exponent of the polynomial. And again, that's kind of simplified if we have multiple variables. Then, for instance, that 2 and 2 on the b squared, a squared would become the fourth degree. So these are classifications. So it's not about math, it's just about what we call things, like naming things. So a polynomial of 0 degree, which would really just be a monomial, one part. If it has 0 degree, if the exponent is a 0, or we don't, not that we don't see an exponent, this would be a constant. Like when there's no x at all, and it's just a number, that's called a constant. If it is first power is the highest, then it is linear. Like we graphed linear equations before. They had x's, but they did not have like x to a second power. If second power is the highest power, these are called, and this one's kind of confusing because for most of us we think of 4 when we think of quad, but they are called quadratics. And then third power are our cubics. In fourth power, I'll be honest, I don't really remember. So I'm just going to say fourth degree. It's not used nearly as often. If you get higher, it's just fifth degree, sixth degree. We just typically call them kind of like how we say third power is cubed, but we could also just say third power. And then naming them by the number of terms. If there's only one term, well, that's what we just worked with yesterday and today. Those are monomials. If there are two terms, these kind of should make sense to you. They are binomials. How about, anyone want to take a guess about 3 terms? Trinomials, good. And we will be using binomial and trinomial. We'll use those words much more often than we'll use cubic or quadratic kind of thing. And then 4 or more terms, we just simply call those polynomials, meaning they have many terms. So they could all be classified as polynomials, but we can be more specific if it only has 1, 2, or 3 terms. So if I simply have a 6, then I would say I have a constant monomial. And maybe I shouldn't have written so big. If I have negative 2x, I have a linear monomial. So we can name it both by how many terms and by the degree. How about 7p plus 1? What degree is that? What's the high? It's a binomial, and then is it a constant? Is it linear? Linear, right? Because it only has first power. It does have a variable, so this would be a linear, and you're right, it is a binomial because it has 2 parts. So number 10, our highest power is 2, so it's that second degree. That's our quadratic. So this is a quadratic trinomial. We're going to work a lot with quadratics. That's what we're working into now because we're going to do a lot of factoring. We'll do quadratic formula coming up. I know some of you are looking so forward to that. Number 11. One name from the left, one name from the right. So highest exponent, in this case there's only one exponent, so it's definitely the highest, 3. So this is a cubic, and it only has 2 parts. Every time you hit a plus or minus sign, that kind of signifies a new part. So binomial. And then this one would be a 4th degree polynomial. On the homework, I want you to mark out number 9 and 10. Okay, I want you to mark out number 9 and 10. And then the other part of this section is really just very much what we have already done as far as when we add it, combine like terms to add and subtract monomials. Just adding and subtracting polynomials. So if it is addition between the two sets of parentheses, it's basically the parentheses are not doing anything. I just put my like terms together, and we want to give our answers in standard form, so we want to go highest exponent first. So I've got these two are going to get together and make just x squared, then 11x and negative 5x, so plus 6x, then 13 and negative 23, negative 10. So very much like what we did at the beginning of this packet. If there is subtraction in the middle, then that means everything in the second set is changing signs. Now, if it is simply all positive, you might just think of it as just subtraction, but because sometimes we're going to have negative numbers, you might find it easier if you think of changing this to plus, and then everybody is switching signs. So if they had been negative, they would become positive. Because they're all positive, maybe just as easy to think of it as subtraction. But 4x squared, negative 3x squared, x squared, 5x and negative 7x, negative 2x, and then minus 1. So again, the subtractions are the harder ones. You can also think of the subtraction before the parentheses as meaning that you need to distribute a negative 1, if that helps you get your signs right. But when we start seeing a lot of negatives, so I can think of this as being a negative, and then negative m squared, negative 2m, and then this becomes plus 5. So instead of changing them inside, I could rewrite, and then I'm putting them with these. Plus 5m and plus 4. So once everything's not positive, it gets a little more confusing to just think of subtraction if you're subtracting negatives and things. And then on page 18, I just want you to do the evens, but you're not going to do number 10. All right, so I just kind of got through all of the notes so that then as people are finishing up, they'll be finished. If you have questions about any of these things or past, then you're welcome to ask. Or if you're working on it, please feel free to stay as you work. So again, in this packet, the homework like this particular page of notes is on page 18. I did not do many of those adding and subtracting polynomials questions because they are very much like what we did back in the adding and subtracting monomials, just more parts.